Hi, Yan Keen, can you hear me?
Yeah.
Okay, cool. Can see you, hear you clearly. Okay.
Oh no. Okay, so let me check my headset.
Have you learned the new things from the PNC tutorial?
Sorry?
Have you learned new things from the PNC tutorial?
Some of them, yeah, I think. I think we should do question 11, then the just say we're doing question 12 and like probability afterwards.
Right. Did you come out of the tutorial with more answers or more questions?
Sorry?
Did you finish that tutorial with more answers or more questions?
I like to think answers.
Yeah, I hope so too. Okay, right. So, what you're on probability tutorial, yes, and then explain a bit about your chemistry. Is there any clarity? What's going on with your chemistry right now?
So
where are we jumping?
We can. I told you we were gonna do carboxylic lecture.
Yes.
On Wednesday, right?
Yes.
Yeah. So the teacher finished the entire thing. I don't know how, I guess she like went through it very quickly.
Right.
But the teacher went through the entire thing. And then that's about it. I guess we're doing nitrogen compounds next week.
So there is no discussion on the lecture of carbonyl. No. Nothing.
It's on SOS.
And your tutorial is still at hydroxy, still.
Yeah. I think we're only at hydroxy. We should be done the tutorial by next week.
Understand. So your lecture is somehow super speeded ahead of the tutorial. That's how it is.
Yeah, I guess.
Right. Okay, then maybe I would like to ask this question on the carboxylic acid lecture. Yeah, which you look at the summary, which reactions are new? Because I am guessing not a lot. I'm guessing that it is repeating a lot of things.
Yeah, it was. There was stuff that was new.
Right. So we should indicate to ourselves clearly which one is new. Because then if it is old, then that's okay, right? Because actually you have gone through them, right? So
I have to fill in the summary as part of the tutorial.
Let's go to this. Oh, you cannot just look at the summary, is it?
Yeah, it's part of the tutorial.
Oh, wait. We can gather a lot from the arrows already, whether this is new or not, right? So again, we are going to concentrate on what is new, but of course, we should also mark what is old. It's easier to do it that way, right? Now let's start clockwise, but let's start from the oxidation, right? The oxidation, new or old?
The oxidation is pretty sure it's old. If we did that in hydroxy, right?
Hydroxy. So you're gonna make a guess. That box is you just label OH. That's your guess, right? That's your guess. So write down O for oxidation and then OH on that box, right? Okay, good. Right. No, the O not on the box. The box is not the O one. The reaction is O, right? The reaction is the oxidation and reduction, I suppose, right? That's old. The box will contain OH, something like that. That's your guess. Hopefully that will help you immediately, right? Now let's go clockwise. Acid base.
I'm pretty sure it is old as well.
Yeah, because acid and base, like how old is that, right? Like super old, right? So then you will get what? Acid base, and you will get
I will get a
acid base neutralization. Neutralization, no?
A salt, I guess.
Yeah, salt. Yeah, salt. That's a good guess, right? So you're gonna guess salt, right? Salt. Okay, clockwise. Acid base. I'm sorry. Before the acid base, I'm sorry. That's redox. I'm sorry. It's redox first. Redox by sodium. I'm sorry. Redox by sodium. Yeah. Sorry. That's why the result is hydrogen. So redox by sodium. No. The acid and base is O. No, I know, but I wrongly read the box, right? The box that we're supposed to look at first is the redox box. The redox.
The NaO and the half H2O.
Yeah. So is that new or O? Redox by S.
It's all I learned it in hydroxy, right?
Yeah. For some reason, they mentioned this in hydroxy. It's very weird, right? For some reason, right? For some reason. So it's still an old reaction, but do you know what the result will be?
I mean, is it a salt or is it like?
That's a good guess. Ion. So we'll see. But the redox O. So just write down the redox as O, right?
Right? Yeah, okay.
Redox. No, redox. Redox Na. You don't see the redox sign, is it? The redox NAS? No. You're not seeing it. It's below the oxidation. Redox NAS RT. Redox NAS RT. You're not seeing it.
Below the.
Put your finger. Put your finger somewhere. Put your finger somewhere. Okay, go up. Go to the right. There. Stop. There.
Oh yeah.
Yeah, that thing. No, you don't have to erase that. Yeah, okay. Anyway, so yeah, okay. So that guy is O. The redox is also O. This is what you say. Okay, this is probably from the hydroxy chapter, as weird as it is, right? It is discussed. Right. So the acid and base will also produce salt, right? Most probably, right? So the box after that is salt also, probably, right? Okay, and then the box after that, acid base Na2CO3, right? It's probably also salt with CO2, probably, right?
Yeah, let me think.
Probably also O. This is like O level O. O level O. Right? Okay, so 4 things O already. Now let's go to nucleophilic substitution to acyl. This is new or old?
I mean, it's old, but
are you sure you have discussed acyl chloride? Because I think you know what it is. It probably appears somewhere, but
not much else, I guess.
Okay, would you like to confirm that this is new or old first?
If they talked about it a lot in the lecture, so
maybe it's new, yeah. Maybe it's new question mark. So let me just put new question mark. Right? You're gonna investigate later, okay? That's your guess, right? Now the box after that, NCN CH3NH2, it will produce a nitrogen compound. Basically, it will produce an amide or amine, right? Either one.
Yeah,
this is probably new, probably new.
I think we learned this in like halogenal compounds.
Because acyl chloride is halogenal compounds, I suppose, yeah, part of it. So would you like to consider this or new? That's up to you.
I'll just say O, despite the fact that I'm going to study this later.
Okay. Then the hydrolysis should be maybe new question mark, same thing. Now, clockwise, the condensation to what? So new or old?
This one is
condensation with alcohol, right? Right.
That's new. Pretty sure it's new.
Yeah, surprisingly, I don't think so. Surprisingly, this will produce ester. This is, I think, the same thing as, is there esterification? There should be esterification.
In hydroxy.
In hydroxy, yeah. This is esterification. This condensation, you can slash esterification. This is O. This is O in hydroxy. So O, this is ester, right? So you can check later. The arrow beside it points to the same box because carboxylic acid with alcohol, ester. Acyl chloride with alcohol, also ester. So this is also considered O, right?
Oh yeah, that was from halogen compounds.
Definitely. That's from halogen. Then the other one is from the hydroxy, right? So both are O. The arrow after this, the CH3CH2OH, that thing. This thing is also from hydroxy, and it will also produce ester. So this is O, right? You can check later. Then turns out that you can reverse ester somehow. You can go from ester to carboxylic acid. Maybe this is new. Maybe this is new. From ester to carboxylate, maybe this is new. You may want to check. I think this is new. I think this is new. Okay. Now, acidification. What's that? What is acidific? How is acidification different from acid catalyzed hydrolysis? That's right. Okay. So this guy probably new. Probably. Do you know what that is?
Acidification. Oh god.
Dilute H2SO4, something with NH3 become that, right? This is probably new, right? I'm guessing probably new. And I think the box after that also new. Now you're gonna check You're gonna check in this chapter The answer will be in this chapter. And then the arrow after that, I think you should also consider that new Okay, because they look very similar. Yeah. Both will be new. I think it will be in this chapter. I think.
Acid catalyzed.
Yeah, so new. So and then the last box the last few arrows from aldehyde to carboxylic acid. I think that's not new. I think that
one was in hydroxy, right?
No, in carbonyl. Carbonyl is aldehyde.
Oh yeah.
And then from that arrow, which is that must be from primary alcohol to aldehyde, right? Primary alcohol to aldehyde. Primary alcohol oxidized to aldehyde. This is also old. This is also old. Okay. Now, how many things are new? 1, 2, 3. There isn't much You just check in this chapter. Okay.
Right.
Okay. So I'll leave this to you I'll leave this to you. What you should be learning mostly is the new one, and then realize that the old one are already mentioned. Okay. Anything else?
But
you won't be doing this tutorial first, You will still be doing the
one, yeah,
which will take care of quite a number of things here. And then you'll go to carboxylic acid. And I think the new reactions are not going to give you trouble. They are quite simple reactions. You check it out. You'll see later. You'll see later.
All right.
Right. Okay. So I'll leave this to you. Okay. Okay. You can close this first. You don't have to worry about this until later. Right. So you are going to discuss. Do you want us to discuss discrete random variable?
Actually, because I'm doing it tomorrow.
Lecture. So
I don't know how far it's gonna get.
Okay, let's talk about it. So you prefer us to do this other than the physics tutorial, for example?
I mean, there's no physics tomorrow. I think physics is next week, right? Yeah, physics next week. And I think you said a long time ago, today is only 1-on-1, so might as well try to learn something new.
Correct. Then let's on Sunday not leave physics behind anymore, because we haven't been talking about physics for a long time. Okay, on Sunday, right? Yeah. So DRV is new. Are you going to have a lecture on that tomorrow?
Yes, I'm pretty sure. Yeah, I am.
Right. As per usual, I speed you up not to cover everything, but to point you out the most meaningful part, and then the lecture will become even more useful for you. One more time, I'm not trying to replace lecture. I'm trying to make lecture very meaningful to you tomorrow. Okay, clear? Yeah.
Right.
Right. So there's a lot of fancy words here. I'm just going to explain it clearly. There's the word discrete. Two or three chapters ahead, there will be continuous. So discrete versus continuous. Right? Now, discrete is not a normal word used in daily life. It's not, right? In normal daily life, discrete means something. What does it mean in daily life? Discrete.
I mean, separate, I guess.
That actually with care, I think it's usually used as being careful, done discreetly, and in somewhat a secret kind of thing.
Yeah,
discreetly. I guess. Yeah, but you are right to say that discrete here means distinct or separate. distinct or separate, and that is in contrast with something which is continuous. So I'm giving you a very rough analogy. In some sense, water is continuous, not discrete in some sense, right?
All
And
right.
then an apple is discrete. That's physically. Now in math, it will be a bit different than that. I want you to flip, and I want you to see an example of a graph. Okay, let's flip. Let's flip.
Graph.
Let's go and find a graph. You should be seeing a graph quickly. Flip again. Flip again. Here, not here, not here, not here. I'm not seeing any graph. They just give you a graph, right?
Okay, I honestly don't think my school will go this far, but sure. Oh, there we go.
Okay, there's a graph here. There's a graph on the left. No graph. Yeah. No, I don't want this. No simpler graph. No bar graph. Simple bar graph. No.
I think.
Okay. This is nice. Okay, you're gonna ignore the nice curve. The nice curve is like water. It is continuous. It's smooth lah. It's smooth lah. Basically, continuous is smooth. But discrete stuff is represented by the bar graph. They are discrete and separate, and therefore less smooth lah. Less smooth. Okay.
All right.
The smooth graph, you're not gonna worry in this chapter. They draw it, I suppose, for a reason, but I don't think that is what is covered in this chapter. Right? So again, discrete, right? Now, there'll be situations when certain things are smooth, and there'll be a situation where certain things are discrete. The most important thing is to know, oh, this question, must be discrete lah. Oh, this question, must be smooth lah. Something like that, okay? Okay. Now, this thing is discrete is very simple one. Oh, 1, 2, 3, 4, 5, or 1 or 0, -1, -2, -3. What I'm saying is usually there is no number in between. There is no 0.1. Whereas in the continuous graph, you can identify any point you want. 0.1 can, 0.99 can, 0.0001 also can. But in discrete questions, those number does not make sense. It's just 0 or 1 or 2 or 3 lah, keeping it simple. Okay, right? Now let's go in front and see the question itself. Let's go in front. Let's go back in front. Right? Go back in front. For any example for now. Let's not worry about this. Let's not worry about this definition. Let's just go. Let's just go in. Go maybe here. Maybe this one. Okay.
This one.
For some reason they For some reason they like to do dice. For some reason, they like to do this. And for some reason, they want you to discuss a tetrahedral dice. Do you know what's a tetrahedral dice?
Yeah, four-sided.
Good, chemistry, right? So
yeah,
the dice can only be 1, 2, 3, 4. Hey, the table is already showing that. 1, 2, 3, 4. First dice, second dice, right? And then the question talks about the sum. Just to be clear, the question can talk about the difference. Also possible, right?
Yes.
So if it is a sum, you can see that the sum possible, first of all, it's not 1. 1 is not possible. I think that makes sense. Something bigger than 8 is also not possible. I think it makes sense. Can ya? Turns out that 2, 3, 4, 5, 6, 7, 8 is all possible. So now they are very discrete lah, because 2.5 is not possible, if that makes sense. 3.9 is not possible, no matter how you slice it. Now you are going to write in the table below something very simple. P, big P means probability. You already know, probability, right? That's big P mean. Probability of the number being 2. Big X equals to small x is a fancy way of saying, well, the probability of it being 2, the sum lah, the sum being 2, the sum being 3, the sum being 4, 5, 6, 7, 8. So we are using probability. Do you realize that? Suddenly in discrete random variable, we're just using probability one. And we are using simply probability. So please, the sum 2, 1/16. Finish, correct?
Yeah. Okay.
The sum 3, 2/16.
2/16, yep.
2/16, I think 3/16, 4/16, right? And then back to, after 4, back to 3 again, then 3 to 1. Now, what is new or not so new lah? Not so new. In O level, this should be like that. What is not so new is that the total must be 16/16. That simply makes sense.
Yes.
And that
That's what's-
is something I want you to add. So I'm just going to add that. I'm just going to ask you to extend table because you realize later on that's important. Just in O level, that is important. The total should be 16/16. It should be 16/16. It should be total of 1, right? 16 over. I'm going to write down 16/16. Just want to emphasize. Now, this probability, many probability, all possible probability is called probability distribution. That's the meaning of the phrase up there. Find the probability distribution of X. Oh, construct this table. That's what it means. Describe all the possible probability is what he is trying to say. Usually in a form of table. And since it is all, the total must be 1. Because all, right? All. Okay, done. Simple, right? We are using probability in a more comprehensive. Questions so far?
None I can see.
I want you to circle the word sum. And now you say sum, the sum, first sentence. First sentence, no, first sentence. Go. No. You don't see the word sum. The score is the sum. The score is the sum.
Score.
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 You're very weird. No. The first sentence of the work example, not the solution.
Oh.
And I ask you to circle the sum, not the score. So the question can ask you the difference. Can. Now, for example, or difference. You're going to write down or difference. Now, the table, you can then say can be minus. If that makes sense. If it is a difference, it is possible for it to be minus.
How does it?
Because we should always be considered. So it's dice 1 minus dice 2, not dice 2 minus 1. So for example, dice 1 minus. So it is possible for small to minus big, for example. Now, why am I trying to say this? Because then the possible outcome can be a minus, because that's how you define the question. You're interested in the difference. So sometimes the probability distribution, the small x will be minus. The big P, definitely not minus. Just want to be clear about this. Does that make sense?
The big P or big?
The big P. The big P is probability.
So the number here can be negative?
No, cannot. Cannot be negative. A probability is always from 0 to 1, right? Always. But the X is whatever you're interested in. If the X is different, it is possible for the X to be negative. Just want to say that. It makes some sense depending on the question. Okay, just want to say that. Most of the X's you see will be positive, but negative is not out of the question. Just want to say that. Okay, that's it. That's it. Let's move on. If there's no question here, let's move on. Most of the question in exam will start like this, exactly like this, right? Will start exactly like this. Here in this question, they actually give you the probability distribution, and it is not symmetrical. That's totally fine. Make sense? The y is also from -3 to 1, and they are discrete. Whatever, you don't tell me what is y, so I don't have to worry about it. It is possible to be negative. I told you just now, it is possible. It's just that they never tell us the story why this is negative. Again, the probability, they never tell us, so we don't care. Okay. But the P, the big P is never negative. In fact, they ask you to find D. Remember, this table is supposed to be all encompassing. So how do you find D?
So this is, the total is 1.
1 minus everything. Okay, done. You know already. That's why look at part 1. That's what they do is 1 minus everything. Make sense? Now, for part 2, it's also simple probability one. He just wants you to sum up the probability from -3 to 0. That's all.
Oh, less than 0.
But it doesn't matter because this is discrete. Less than 0 definitely includes 0. Wait, let me think for. No, less than 0 never includes 0. Just include -1. In discrete it matters. Right? So I hope that makes sense.
All right.
So y bigger than -1, he does the simple thing. He does the, I think, oh no, he doesn't. No, he just adds 0 and whatever.
All right.
Okay, simple stuff, yeah? Nothing complicated.
Is it?
Go. Right. So now they use the word summation here, the notation summation, and then for some reason they give you a formula for the big P.
Okay.
So instead of a table, it is a formula. Yeah, I mean, it's possible to do that. Would you like to write that down? That right now the table is being replaced by a certain formula. Okay. Doesn't matter lah. Doesn't matter lah. You use formula to find whatever information you need from the table usually. Right? That's all. That's all.
So I just
look at what the solution is saying. The solution is not done, right? So he wants you to find the value of C for the formula. What he's writing makes a lot of sense, you know. Summing up all the probability will give you a total of 1. That's what he's trying to say. Make sense? Right? That's what we have been talking about since just now. Summing up all the table, the P will be 1. So summing up the C4/5x will be 1. Let me see, yeah. The x will be bigger than or equal to 0. So does that mean that the table is infinite? Let me think for. Wow, the table is infinite. Because he say x is integer number, no? Right?
More than or equal to 0.
Yeah, so that is from 0, 1, 2, 3, 4 until infinity. Wow.
Yeah, but it all eventually rounds down to 1.
Yeah, and do you know what this reminds me of? This reminds me of geometric series law.
Okay.
This reminds me of geometric series where C, it must be the first guy of the series because C 4/5 to the power of 0 equals to C, right? So we're going to write down the series. We're going to write down C and then say summation plus, right? Summation, then C plus what? C plus 4/5.
4.
Right? C 4/5, right? To the power of 1C lah, right? Yeah, 4/5 times C. You are not making a lot of sense. You're not making a lot of sense. It's just C times 4/5.
Sorry. Let me give me a sec. Let me get my EPGP.
No. Stop there. Stop. Why do you put the C as the power? The power is 1, right? The power is 1 times C. So 4/5C lah.
1 times. The power is 1. 4/5. Wait.
To the power of 1 times C, right?
Times C, not plus C.
No. The first guy is C. No. The first guy is C.
So
the first guy is C. The first guy is C. C.
Oh, C 4/5 to the power of 0.
Yes, and then 4/5 to the power of 1 times C. So 4/5 C, great. And then 4/5 to the power of 2. Okay, C, and then so far and so forth, right? Dot until 4/5 to the power of infinity times C, right? Right, times C. Now, don't take your AP/GP. I know it has been a long time. Don't you recognize this as either AP or GP?
Yes.
Which one?
Pretty sure this is no.
Look, AP
GP.
means for each for each series for each unit, right? For each unit, you plus or minus, right? For GP, you times right? That's all.
So AP.
Oh, you don't know.
No, wait, it's GP because
it's GP.
The power is 3.
Yeah, because everything you times 4/5 times 4/5 times 4/5. Correct or not? So you're gonna draw arrow lah. You're gonna draw arrow skipping from first one to second one to third, from first to second first, from first to second first, from the first to the second one first, from the first. Yeah, it's also times 4/5, right? Okay, so AP or GP? Don't you skip like that. That thing doesn't make sense. You just skip per unit, right? You just skip per unit. But you know that per unit is just times 4/5 lah. You know this already. You can see that, right? So this is AP or GP?
GP.
Right. So this is GP, and for GP, you need the first guy, they call it A, and you need the ratio lah. You already know both, ma? Correct? You know the first guy. The first guy is C. Ratio 4/5. Done. It's GP. You know this. This is S infinity of that GP, lo? Correct? S infinity. Summation until infinity, lo? So you're gonna write down S infinity. I'll give you the formula. Good. Equals to A, which is the first guy, over A over, 1 over R. 1 minus R, I'm sorry, 1 minus R. 1 minus R, 1 minus R. Write down A over 1 minus R first, just to remind you, right? Just to remind you. A over 1 minus R. Okay, then you can put in the numbers. And he's saying that this should be equal to 1, basically lah, ma. So you can find C. Okay. 1/5, right?
1/5.
Yeah. As weird as this is suddenly a GP lah. Okay. Okay.
Oh.
Right. So I'll leave part 2 for you. You're supposed to look at GP again. I'll leave part 2 for you. Okay. Okay. I'm going to skip through this because not a lot of probability distribution is GP or AP. This is just forcing it lah. Most of them are not. Right. I just leave it to you.
There's constancy again.
Right. So for some reason, now the probability distribution is not a table, it's not a formula, it is this thing. So just write this down. This thing is not a table, it's not a formula, but this thing is this thing, and I'm going to read this thing, I suppose.
Okay.
Doing this, but okay. So again, please write down something here like this replaces the table and or the formula. This whole thing. And the total must still be equal to 1. That's just always the same. So the x is discrete, right? The x is discrete, it's not continuous, it's minus 1, minus half, 0, 3/4, and 1. Don't know why the x is like that. But if you want to construct the table, you can. Would you like to construct the table? It is quite easy to do.
Oh, sheesh. I guess it's not that hard.
Yeah. Let's do that if it makes it better for you, right? You should always try. Now, how many tables would that be? There will be 5, I suppose, right? There'll be 5.
1, 2, 3, 4.
Right, 5 column, 2 row. I mean, actually, yeah, 5 column, 2 row, right? Why are you making? Why are they making the table like this? Sorry.
What am I doing?
What are you doing? Yeah, I don't know what you're doing. The table is simple, right? The table is the Jamboard, right? So it's just like that, right? It's just like that, right? Just like that, just divide, 1, 2, 3. I'll divide to 6, right? Just do it. Why 6? Because we need 1 for the for the symbols lah. Yeah, we haven't even gotten to the big essence. So 1, 2, 3, 4, 5, 6. Let's do 6. That's 4. So 2 more, right? 5 and 1 more.
2, 3, 4, 5.
Okay, so what should you write in this table, right? The top row is x, right? The value of x, right? Whatever
so
x
minus
is.
1.5.
Yeah, but start with x first. Just write down x here. Yeah, x, and then minus 1 next to it. Yeah, minus 1, minus half, right? So these are the discrete variable, right? This is discrete variable. Never mind the word random. This is discrete and variable. Okay, then below is probability, right? Probability when big X is equal to X, right? Okay, so that's CX squared. This is also CX squared, and then that's 0. No, that's X, I'm sorry. Then that's CX and then CX. Now, will this table be able to make it easier for you, right? So everything add up must be equal to 1, right? That's what it means.
Okay.
That is what he's writing below there. Correct or not? That's just what he's there.
Px. I guess it is.
It is, right? Close to 1. And I think I'm guessing that he wants to find C. Though. The question doesn't ask you to find C, but I think that's what he wants to do. He wants to find C. I think that's what he wants to do. So go and find C, and then you can do it by yourself later. The rest. Could you please shift up? Right, thank you. Now, what does X mean? C is something to find. How come X we don't have to find?
I mean, don't we? No, wait.
The X, you just use -1. Just use -half. Just use 0. Correct or not?
Oh, stop X equals to -1 so that.
Correct. Because that's
0.
what the X means. Oh, the X means, oh, that guy. Oh, okay. So, okay lah, use it lah. So now use it, please. C is 1 square, right? C -half square, right?
So it's C1. So that's C...
No. -1 for the first guy, -half for the second guy. You're not supposed to write this. It's very confusing. Please don't write. Please don't write substitute. Please don't write substitute that. That is very that's very misleading. It's very confusing.
What do I write then?
Go back to the table. Yeah, the second column, right? You see CX square, right? Now that CX square will be C -1 square. That guy. The guy next to it is not C -1 square. That's C -half square.
Oh, okay.
Right? That's what X means. The X is the guy above, correct?
Oh dear. Okay. So
this is confusing and simple at the same time. So please do that. Square. Where's the square? Yeah. Thank you.
plus C3/4 plus C.
Yeah. So what he's saying is, even though it's CX, the CX is not the same. The CX square is not the same. That's what he's saying.
Oh boy.
Does this make sense? Is this concrete? No, this is super abstract. This is annoyingly abstract. I find this to be not. This is not. I don't think this is how I will introduce the chapter, right? But that's how it is for now, right? This is very abstract. Again, I disagree with the way this is being done, right? But this is how you do it. You're gonna do it later, okay? You're gonna finish it later, okay? Let's jump to the next page. You're gonna finish this later, right? Never mind this. You can do it by yourself.
Honestly, I don't think my school will go this far.
Of course not. We're always going faster than your school so that you can enjoy or you can understand the lecture better. Yeah, right. So mean, median, mode, you know what they are, right? You know mode.
Generally, like average, and then the middle, and then the mode. I'm not too sure.
So you can also read mean, median, and mode in the table itself. Let's go to the dice. Let's go back to the
dice.
Yeah, there. So I'm asking you, what's the median?
Median is 216. I mean
2, 3, 3, 4, 4, 4, 5, 5, 5, 5, right? 6, 6, 6, 7, 7, 8. The median is between 5 and 5, right? Between the center 5 and the center 5, no? That's the median. No? The median must be 5 plus 5 over 2.
5 plus 5 over 2 is 5.
The median is 5. Make sense? The median sum is 5, not probability, it's the median sum, right? What is the mode? The mode sum, the most frequent sum, 5 also lah.
5.
Easy, right? Because the probability is the highest. If that makes sense. Oh, the probability of 5 is higher. Must be the mode lah. Simple one.
Oh.
That makes sense, right? That makes sense. Okay. The average, you have to just sum up everything. That's all. My guess is the average is 5. My guess the average is 5 because the distribution is symmetric. That's my guess. Okay.
Yeah, 1, 2, 3, 4, 5, 6. Yeah, 7. Yep, it's 5.
One thing I want you to note here is that the mean, median, and mode of course, has some relationship to the probability, but it's mostly on the X, not on the probability. Okay, just want to say that. Not the probability, is the data itself, so to speak. I think the three of them works that way, mean, median. If they ever want you to. This one suddenly makes more sense than the thing just now, like the super abstract thing just now, right? This makes more sense.
Yeah, I guess.
Okay, let's go on. Let's go on. Again, they give you a table. They don't tell you why, but this looks like something easier. I mean, they're just asking you to identify the mean, median, and mode. Obviously, the mode is 1, right? Obviously, right? The mode is 1 since the probability is the largest, right?
The probability of, wait, isn't it? Oh yeah, 1, that's 0. Yeah, okay.
So the mode is 1 since the probability is largest. Tara, finish. Now you're gonna read for yourself how to find median and mean in such a situation, right? You're gonna read yourself and see whether, okay, just write down the question mark for median and the mean, so that you remember how to do it, how to check it out later. If the method doesn't make sense, we have to discuss it, or the lecturer will just explain.
I assume it's 2.
No, because 1 higher probability means there is more 1. I don't necessarily. No, I think the median is 1 because the 0 is 10%. 0 is 10%. 1 is 45%. Both 0 and 1 already 55% of the whole data. Correct? And median is the center value, means position 50%. Remember how you define median is Q1, Q2, Q3. Q2 is Q2, the 50%, the 50 percentile.
Oh.
Median is center value, means 50th percentile, right? 50th percentile, definitely 1, not 2. I hope this makes sense.
Oh. So it's the value for which there is at the 50th percentile.
Yeah, center value 50th percentile Q2. That's what it means. Okay.
Okay.
Definitely 1 in this case. Definitely 1 because it's already until 55 percentile. 55th, sorry. Right.
Okay.
Now the mean is something that you have done in O level also. Actually, this is repeating O level. So if you don't understand the formula of the mean, you think about it for a while. If you don't get it, then ask me again. Okay.
Is it? I always thought of it as like average, but is that like good enough for A levels?
It is average, but the formula you have to understand, right? Not rest. The formula will 0 times 10% plus 1 times 45% plus 2 times 10% plus 3 times 30% plus 4 times 5%. Everything divided by 1 in this case. So done. That will be the mean. I'm going to ask you to think about this yourself. This happens in O level. It happens in O level. There's nothing new here, right? So let's go to the next page. We haven't hit the essence. Expected value is the essence lah. Now, expected value is the average value is the mean. So they already write down the expected value is the mean is the average. Average is the most important thing, guy, is probably what he's trying to say.
Wait, expected value is denoted. We often use it.
Up, go up. It can be seen from above that the average value is known as the mean or the expected value. So average is mean is expected. They are just the exact same thing. So when they say expected value, they're asking you what's the mean value.
Okay.
Okay. Now let's go back to the dice, and I'll leave you alone. Go back to the dice.
Go back to the dice. Right.
Now, the word expected will be very weird, to our brain. I will use the synonym first. The synonym is the mean, right? the mean of this whole dice thingy is 5. The mean sum definitely 5. Make sense? If that makes sense, I'll show you lah. I'll show you. Okay. I'll show you first. Again, although the word is expected in this chapter, I will use the word mean. Okay, watch the Jamboard.
Yeah, watching it.
Why is it 5? Well, not because there's a lot of 5. No, that's not the point. The point is, look, 2 and 8, the average is 5.
2 plus 8 divided by 2 is, yeah?
Yeah. 3 and 7, the average is 5. Right? 4 and 6, the average is 5. And of course, lastly, 5 is 5 lah. So everything when you average will be 5.
Is
correct?
This? Wait, let me. Why can't it be like, I don't know, like 3 plus 8 and then or like 4 plus 7 or whatnot?
No, you can. You're missing the point though. The most literal thing is like this: 2 plus 3 plus 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6 plus 7 plus 7 plus 8. Everything divided by how much? How many?
Divided by 16.
Correct. You can 3 plus 8. You are supposed to do that. You're supposed to 2 plus 3 plus 3 plus 4 plus 4 plus 4. You're supposed to do that. But why bother? You have logic what? I see the both end, average 5. I see the second place, average 7. I see the third place, also average 5. Sorry, average 5. So the average must be 5. I'm just using logic here to shortcut things. That's all.
Okay.
I'm not bypassing the supposed formula. You're supposed to present the supposed formula anyway lah.
All right. Okay.
Right. So the mean value here or the average value here is 5. You write it down first. The mean or the average value is 5. Now here comes the weird thing. The weird English word. Therefore, if I roll 2 dice, 2 fair tetrahedral dice, I expect the value to be 5. Now, does that make sense?
No.
Okay, then I'm going to make it sensible. I expect on average the value will be 5.
Okay.
Okay, that's what the word expect means. Every time it comes up in a question, it does not mean that everything is 5. It does not mean that you expect it to be always 5. It means you expect it on average to be 5. It can be 8. It can also be 2. It can be 7. It can be 6. It can also be 4. It can also be 3. Averaged properly, it is 5.
All right.
That is the meaning of the word expect. Again, if you expect it to be 4, you will be slightly disappointed because there is less 4 than 5, for example. Or let me say, if you expect on average it to be 4, you'll be disappointed because look at the triangle. This triangle is smaller than this triangle. I think the expected value of 4 is wrong. Maybe I put it that way. I think you should expect slightly higher in average. That's what the word means. Okay?
Oh boy, it's okay.
So, that is the most important part in discrete random variable. The expected value is just average. Okay?
Oh.
Right. So tomorrow you'll probably not hit that thing. So good for you. Any other question?
No, I think I just not yet, I suppose.
Yeah. So your mindset is that you have a lot of questions right now and it's so crammed in your mind, correct?
Yep.
Please don't be double set. just be one-time set. Oh, I have a lot of questions. Oh, I don't understand. Oh, this is so abstract. Please don't do double set. You go into tomorrow's lecture with questions. That's a good thing. Imagine you hearing about this without even knowing what's your question. I don't think that's helpful. Like today, you're having this headache. Like this is so annoying. This is so abstract. But tomorrow, your headache will be less, not more. Am I bluffing you, or is this what is happening? Like every time we do this, that happened tomorrow. Right? Tomorrow, your headache will be less, not more.
Yeah, that happens.
Okay, no? So your headache is today, good for you. Tomorrow, good for you. I mean, okay?
Right, okay.
Good. So I will see you on Sunday, and I hope we will treat the physics fairly on Sunday. You may want to ask other things, but again, I hope you will be treating the physics fairly.
Yeah, probably
Giving it its time. Yeah.
to
Giving it
superposition.
right. But remember, please rest on Friday, Saturday, and Sunday morning. Okay. If you do that, your next week will be great. If you don't do that, out of whatever reason, it's not good for your next week. It's not good. Okay.
All right, okay.
Bang, bang, bang. See you on Sunday.
Bye-bye.
Bye-bye.
Bye-bye.